McComb with Semantic Arts. We're a consulting company that helps large organizations with their enterprise software and their enterprise software architecture. We also specialize in helping clients introduce semantic technology into their enterprises. And so one of the things we do a lot of is modeling, in particular semantic modeling. We do enterprise models and the like. And one of the things we discovered was that both our clients and occasionally ourselves get confused about what kind of a model we're building at any point in time. And so somewhere along the line we came up with what we now call the tic-tac-toe methodology as a way of kind of explaining and talking about the different kinds of models as you're building and using them. And as you'll see why we call it the tic-tac-toe methodology. It looks like a tic-tac-toe board. If you're familiar with the Zachlin framework or some other things, this will look sort of similar, although in a lot of ways much of a simplification. What we do with the tic-tac-toe methodology is say going this way is different levels of abstraction. So we have data, so individual instances of specific data. We have metadata, and we have what some people call meta-metadata. Sometimes you call it a grammar. It's a way of describing the metadata or the classes and properties you have, which is a way, again, of describing or giving information about the data you have. And then coming down, we're bringing structure or more commitment to specific design ideas. A lot of people call this top level the conceptual model or the conceptual world, but we like to refer to it as the real world. And then this as the logical model or the logical design world, and then the physical implementation. So up at this level, we might have things like, if we were doing a legal ontology, we might say that we've got Johnny Cochran up here in the upper left, an individual person, a lawyer. We might say we have the class of all attorneys there in the middle. That's a real world kind of a class. And we might have an abstraction of that, like perhaps legal roles might be a way of saying that these kinds of classes are legal roles, and Johnny Cochran is an attorney. Coming down, people are much more familiar with how a conceptual model can translate into a logical model, can get translated into an actual implementation, like a relational database or something. But where it gets interesting is this. Most people are used to doing logical data models kind of in the middle of the tic-tac-toe board here. It's where entity relationship diagrams are. It's where most designs that most people are familiar with are. And when people do conceptual models, they generally take the skills they learned here, apply them up here, and end up with conceptual models that look a heck of a lot like logical data models. Maybe they've left out some junction records or a few things like that. But what we found that's interesting is up here, using semantic technology, things like OWL, we can build an enterprise ontology. And the enterprise ontology, even for a large enterprise, we've done this with several very large enterprises, very often is anywhere from about 500 to 1,500 concepts, covers pretty much everything that happens in the enterprise that's of note and is important to the structuring of the information. There's obviously much more detail and many more distinctions when you actually get into it, but what really holds the systems and the companies together, what provides the systems integration, can be defined at that level. And then we can derive logical models from this enterprise ontology. And the advantage of doing that, especially if you have many different kinds of logical models, so you might have a logical data model for your transaction system, you might have a logical model for your data warehouse, you might have a model for the messages in your SOA architecture, etc., etc. If they were all derived from the same set of concepts using the same terms, you'd end up with something that was far easier to integrate, far more reusable, and an actual real asset. Then from here, this technology is already pretty well known, how we come from logical models to physical models, and that's a pretty apparent model progression there. So, we look at this because a lot of times when people are doing what they believe are conceptual models or enterprise models, they start introducing constructs or constraints that are typically peculiar to an individual application, maybe even the design of a document. They get introduced up at the top, and that makes the whole thing a lot less reusable. So that's our little methodology, that's our way of thinking of how models relate to each other. Hopefully that's helpful for you in your modeling